Okay, so today we are doing 1.7, which is titled Inequalities. And by the end of today, we are going to understand how to solve nonlinear inequalities. So the first thing that I highlighted was that in order to solve inequalities, we have to use factoring. Okay, so the factoring is going to be a reoccurring theme here. And this is inequalities involving squares and other powers of the variable. So nonlinear inequalities are ones that have different powers. You guys solved linear inequalities in Algebra 1. You actually did do a few quadratics in Algebra 2. And now we're going to have a few other forms as well. And then hopefully a new method than what you did last year. Okay, I'm going to give you guys a minute and we're going to work with your elbow partner. And what I want you to do is just first compare to see what each of you highlighted. And then the person on the left is going to summarize that first box. The person on the right is going to summarize the second box to the other person. Okay, so compare. The left will summarize the first box, the right will summarize the second box.
Alright, first box. You got an even number of negative factors. All the negatives cancel out, it's positive. You got an odd number.
You put each one equal to 0, and then you solve that, see what the interval is.
Yeah, I didn't get past it before. I didn't give a shit. I don't either.
As to solve, it seems like we already did solve.
Yeah, I know.
Alright, we're going to wrap those up and we're going to share with each other. Alright, so that first box, Farai, what did you and Delaney discuss about that first box?
I think that was interesting. We said like, the part one said if a product or a quotient has an odd number of negative factors, then its values is negative.
Okay, so if it has an odd number of negative factors, then the value is going to be negative.
Yes.
And then what was the other part?
Also for me, for me or?
You're doing so well. Why didn't you
Oh,
just
me?
go?
Oh, okay. The other part was the top part. It says if a product or quotient has an even number of negative factors, then its value is positive.
Okay, so were you guys able to summarize what each of those meant with each other? I want you to be able to put them in your own words. So, something that you guys have probably been talking about in other classes is annotating the text as you read it. That's especially helpful. Remember, this is a college textbook that you guys have. You're going to see these blue boxes of information, and then it's important that we be able to interpret what they mean. So what I did is I just put a little notation on the side. So if I come back to study this, I'm not going to have to read through all that. I'm going to be able to see it and know exactly what it was telling me. So we know that if you have an even number of negatives, the result of that, if you multiply or divide, is going to be a positive, right? And that's because if you have a negative times a negative, it'll be a positive. So if it's an even number, it'll be positive. If there's an odd number of negatives, then the result is going to be negative. All right, then you guys talked about your steps for solving, and this is for solving nonlinear inequalities. So it said the first thing we're going to do is move all terms to one side. So the first thing we're going to do is, okay, we'll try one more time for the people in the back. We're going to move all terms to one side. What are we going to do first?
Move all terms to one side.
right side is going to be 0, and then everything else will be moved over. Okay, our second step is we are going to have to factor. So secondly, we are going to do what? Factor. Then we are going to find the intervals. Now, what I mean by finding the intervals is you have to find values for which each factor is 0. So that's going to be really important. So in order to find the zeros, if you don't already have this underlined or highlighted, then you're going to want to do that. You want to determine the values for which each factor is 0. Then I wrote a little interval for you underneath to just remind you how we can set up intervals from the number line. So if you have two arbitrary values, we'll call them A and B, they're going to break that number line into how many intervals? Okay, it's going to break it into 3 intervals. So the first interval, it would go from negative infinity to whatever your A value was. Your second interval would go from A to B. The third one would go from B to infinity. So I know that looks a little hard to read. That is B to infinity there. Notice that I used hard brackets. Okay, so keep in mind, I'll ask you a little bit later about when we have hard brackets. Sometimes we are going to use just the hard ones. Other times we'll use soft brackets. And then in special cases, we'll also have a mixture of both. So as we go on today, we're going to talk about what those special cases are. After that, we are going to make a table or diagram, and you guys probably already noticed that I made a table for you that you're going to use for our examples today. I'm also going to show you how you can make a quick diagram on your homework without having to draw everything out, so that'll go quickly for you. Now, when you make a table or a diagram, this is really important. What we're going to be doing is we're going to find test values. Okay? And to find test values, you're just going to find points in that interval. We'll go over that as well. And then finally, you are going to solve. And when you solve, you're going to be using your diagram. In particular, you're going to be using the last row. Okay, so that might be something that you want to highlight or underline, that you're going to be using the last row of your sign table. Okay, so now we're going to put some of this into practice. So when you're reading the directions for the first question, what I like to do when I'm reading them is underline or highlight any part of the direction that's going to be important. So we'll read these together and then we'll underline important parts. So for example 1, it says solve the nonlinear inequality, express the solution using interval notation. So that's giving me a specific direction on how my answers should be formatted. Okay, so I'm going to have to put it in interval notation. So all of your answers for this are going to be in what notation? Interval. Okay, and then we are also going to graph. So it says and you are going to graph the solution set. So when you're graphing the solution set of an interval, it is going to be on a number line. So your solution is going to have 2 pieces, the interval, which is obviously an interval notation, and the graph of the solution set. Okay, so let's go ahead and solve a nonlinear inequality. So for the first one, we have x squared minus x minus 2 is less than 0. Okay, and Emily, will you just remind us what our first step is? Okay, move all terms to one side, so I have 0 on the right side. Do I have 0 on the right side? Okay, so step 1 is already done. Okay, so that's already done. All right, and then, Evan, after we move all terms to one side, what's my next step? Yep. It's okay. Okay, so we are going to factor. All right, so when you factor, you have x squared, so how am I going to start my parentheses? X and x. And then the 2 numbers, Will, tell me what the 2 numbers have to do.
-2 and 1.
No, tell me what they have to do. Don't tell me what they are. Tell me what they have to do.
equals 0.
Not equal to 0. How did you find that? The two numbers that you put here have to do what?
Equal -2.
Okay, so they
Multiply
have to
-2 and add to -1.
exactly. Okay, so they have to multiply to -2. They have to add to -1. Okay, so the only things they're going to multiply to -2 are yeah, 1 and 2, and it's either 1 is negative or the 2 is negative, while the other's positive. Okay, and then Will, you said you came up with x minus 2 and x plus 1?
Yeah.
Okay, so if we check that, in the middle I'd have -2x. On the outside I'd have 1x. If you still are struggling with factoring, I recommend that you do this. So I got -x, that's what I wanted, I'm all set. If you foiled and you got the same term except the opposite, do you guys know the only thing you'd have to change? The signs, then you would just flip them. Okay, for step 3. Step 3 says I have to find the intervals, and I do that by determining the values for which each factor is 0. So we're going to look at this factor first. Nathan, I'm going to have you do this one with me. Okay, so Nathan, what could I plug in for x that would make this factor 0? 2. Okay, so that's one of your x values. Okay, and then Joanna, for this factor, what could I plug in for x that would make that 0? -1. Okay, so my two values are going to be 2 and -1. And again, I got those because those are the two values that when I plug them in, I get 0. Okay, questions for me so far? Okay, the next thing I'm going to do is I'm going to put these on my number line. When you put them on your number line, they have to be in numerical order. So what comes first, the 2 or the -1? The -1. If you don't put these in the correct order, then your intervals are not going to be correct. Now, before I write my intervals out, I have to know whether I'm going to have soft brackets or hard brackets. Do some of you already know? Yeah, Kyla, what do you think soft?
Because the sign that says less than is less than.
Okay, good. So we have to go back up to our original problem. So in our original problem, see how this is just a less than sign? If it's just less than and there's no equal to, then that means that you're going to have soft brackets. And yes, I would write that down. Okay, then we can set up our intervals. Okay, so my first interval will be -infinity to -1. That covers this part of the number line. The next portion would be -1 to 2. The last portion is going to be 2 to infinity. And then what we're going to do is we're going to take those values and we're going to write them in our diagram.
Can you see those in
Okay, so once you have your intervals, you're going to write them in your chart. Okay, so then our intervals are going to be -infinity to -1, -1 to 2, and 2 to infinity. Now see on the side where it says sign of, that's where you're going to put your two factors. So your two factors we get right from here. So the first one is x minus 2. And then my second factor is going to be x plus 1. Okay, and again, those are the factors. That's where those are coming from. Now earlier we talked about test points and how we have to have test points. And we're going to pick test points for each interval. So when you're choosing test points, your test point might not be the same as the person next to you. That's fine. We're going to choose them together for the first one. When you're choosing a test point, it just has to be inside the interval. It can't be any of these numbers. Even if it was a hard bracket and it was inclusive, it would be inclusive in two places, which means it's in an indeterminate value. So you'd have to choose something else within the interval. So none of the numbers you see on your interval parts right now will be selected. So this is negative infinity to negative 1. Okay, Brigitte, what's a number from negative infinity to negative 1 that you want to try? Negative 5, sounds good. Okay, let's look at our second interval. So negative 1 to 2. So Julia, what's a good number between negative 1 and 2? Okay, 1, good. And then Sam, can you help me out with my last one?
4.
Okay, good. So something had to be bigger than 2 all the way up to infinity. Questions about how we're choosing the test points? So it can be any number in that interval. Okay, so then let's go ahead and plug it in. So when we do the test point, we physically plug it in here. So if I plugged in negative 5 minus 2 would be negative 7. What I would just have you write down from that is a negative. Now, because this is the first time we're doing this, I am going to just write at the top, we got that because negative 5 minus 2 was equal to negative 7. Since that's a negative, we put down the negative. Then we're also going to substitute into the second factor. So if I plugged in negative 5 plus 1 is going to be what? Negative 4, and then that is a negative. So I would put the negative. And then let's look at what the last row says. It says sign of the product. So if you multiply a negative by a negative, the product is going to be positive. Okay, please go ahead and if you feel like you can do the rest of the chart, do it. I am going to walk you through the first part of the next one. So with 1, if I plug in 1, 1 minus 2 is negative 1. So this would be a negative. And if I plugged in 1 to the bottom factor, 1 plus 1 is 2, which is a positive. And then a negative times a positive is a negative. Okay, so see how you don't have to write what's in blue there? I just wanted to show you where those were coming from. If you haven't already, I want you to do the last column. Okay, if you have done the last column, I want you to ask yourself what you think the solution will be. Okay, so Farai's going to walk me through this reasoning. So go ahead and tell me how we do this, Farai.
So 4 times negative 2.
Nope.
4 minus 2 is 2.
Yep.
So it's a positive.
Yep.
And then 4 plus 1 is 5, which is a positive.
Yep.
And then positive times a positive is positive.
Good. Okay, now remember, when you are doing this, you can also think of this like the way the first box explained it. So see how I have an even number of negatives? Then the result is positive. here I have an odd number of negatives, so my result is negative. Isa, do you think you know what interval is the correct one for my answer? Okay, can you tell me why?
Two positives times negatives on it. I don't know, I don't know.
That, so we're gonna have a solution, right?
Yeah,
Okay, so we have 3 intervals, right? So we have to pick 1 or 2 of those that are gonna be an answer that satisfy our equation. It's okay if you're not sure, I know you might know. Okay, but do you know why? Okay. But this one's a negative times a negative is a positive. Why does that matter? Does anybody think they do know? Yeah, Kyle?
The odd number of negatives.
That, nope, has nothing to do with that. Shannon?
Factors
Nope, nothing to do with that either. Okay, so let's look at the original problem. Okay, so you have x squared minus x minus 2 is less than 0. You're trying to figure out what values would make that true. So if you have this equation, this expression is less than 0, right? What types of numbers are less than 0? Negative numbers. Okay, so it is going to be the middle one, but the reason why is because of this sign. So for your notes, I'm just highlighting this. Okay, so it is going to be the middle. We are also going to go back, and we are going to write here that because it is less than 0, we are looking for the negative interval, or intervals, depends. Okay, so less than 0. If it's less than 0, okay, then we're looking for the negative intervals. Which means that this sign was flipped the other way, my 2 intervals would have been the 2 positive ones. If you have 2 intervals, do you guys know how we, or remember how we have to link them together? Yeah, with the union. Okay, good. So you might have a situation like that. All right, let's try the next one. Okay, so the next one is 2x squared plus x is greater than or equal to 1. Oh, sorry, I did not write out, you're right, I didn't write out the solution. Okay, so let's go ahead and write out our solution before we try the next one. Okay, so your solution is going to be the interval that makes that positive, and then we're also going to graph that on the number line. So negative 1, 0, 2. So negative 1 to 2, because they are soft brackets, those are open circles. And then you would connect them. And then let's talk about what this solution means. So negative 1 to 2, that interval includes all the possible answers that would make your expression true. If a number was outside that interval, then it wouldn't be true. Okay, so if I were to plug in a number in between negative 1 and 2, let's say 0. If I were to plug in 0 here, right, this would be 0 minus 2. I'd have negative 2 is less than 0. Is that a true statement? Okay, let's try 1, because that's in between their 2. 1 squared minus 1 is 0. 0 minus 2 is negative 2. Is negative 2 less than 0? Yes. Okay, let's plug in a number that's outside of my interval. What's a number that's outside of my interval? Okay, so yeah, negative 1 or 3 or 12, yep, any of those would work. If you plug in negative 1 squared is 1. 1 minus negative 1 is what? Like a plus 1. So 1 plus 1 is 2. 2 minus 2 is 0. Is 0 less than 0? No, it's equal to. If you plugged in 3, 3 squared is 9. 9 minus 3 is 6. 6 minus 2 is 4. Is 4 less than 0? No. Okay, so anything inside your interval should produce a true statement. Anything outside your interval should produce a false statement. Yeah.
So when we're doing step number 4, if
Yes.
it's a greater or equal to question,
Yep.
and we're using the sign of, what happens if your answer ends up being 0?
That right. So if it is the equal to, so you have the closed brackets, those are going to be indeterminate points that are shared by them. So don't choose that one.
Okay.
Okay. All right, and then you guys can try part B.